So far, we've been talking about firms that take prices as given. And today we'll start talking about market power, which will be a focus throughout the rest of the course. So I'll begin by talking about what is monopoly and why does it arise. I'll then talk about how monopolies price. Then I'll turn to the monopoly distortion and the welfare impacts of monopoly, in particular contrasting the incidence of taxation under competition versus monopoly and applications of the logic of incidence. I'll then talk about regulatory solutions to the monopoly problem, average and marginal cost pricing, and I'll talk about the distortions that each of these cause. I'll then talk about the relationship of average cost pricing to what are typically called selection distortions, adverse selection, things like that, and the empirical measurement of that, and we'll apply that to the regulation of the health insurance industry. Okay, so monopoly sort of sounds like there's only one company producing a good. But of course, every good has substitutes, and no good is, perfectly substitutable with any other good. So it's not really possible to define what it means to be a true monopolist, because every restaurant in this area has a monopoly on selling exactly what that restaurant sells, and at the exact place that it sells it. And on the other hand, none of them has a complete control, and no company has complete control over any particular product, because there's always things that are at least somewhat substitutable for that product. So even if you were the only manufacturer of steel, there are other metals that are substitutes for steel that if you started charging too high of a price, people would substitute to. So really, the notion of monopoly applies to any firm that doesn't take the prices of its products as given. And that includes any time a company can affect the price of things that it purchases as well as things that it sells. So that's often called monopsony rather than monopoly. Now the question is really just how severe is the distortion induced by monopoly? So the key question when we choose to use a monopoly versus an oligopoly model is not whether the firm faces any substitutable products, but rather that the monopoly model will focus on particular aspects. So first of all, the monopoly model focuses on the direct effects of any intervention that we have on the monopoly through the prices of that particular firm, rather than the effects through changes in the behavior of other firms that sell substitutable product. The monopoly takes all these other changes as fixed or small, whereas an oligopoly model will try to explicitly model them. We'll also assume when we talk about a monopoly model that we won't think about the existence of other products which are complementary with that product and which may be indirectly affected through this. So we'll ignore that. Second, monopoly is going to ignore the welfare effects that come through changes in the profits of other firms. It will only think about the welfare effects that come directly on consumers, and we'll see how important that will be when we get to talking about oligopoly. Monopoly models can't be used to think about cross-firm externalities. And finally, monopoly models can't be used very effectively to think about changes in the structure of firms in an industry. So for a topic like merger analysis or the effect of changes in the degree of competition, monopoly is going to be useless because it's not going to give an explicit model of how those affect what the firm does. So instead, it's going to focus on the incentives of one firm and provide an input to our analysis of other issues. Okay. So what causes firms to have market power? Well, the reasons that firms have market power are usually divided into two categories, quote-unquote natural reasons and quote-unquote unnatural reasons. So let me first talk about the unnatural reasons. And these are very similar to the barriers of entry that we talked about earlier. So one of these is intellectual property. That is, a firm has some secret information about how to produce something, or its information is public, but the government says that it's the only firm that's allowed to use that process. And that's going to be the focus of the lecture on Tuesday. We'll talk lots about intellectual property. A second reason might be lobbying or government protection. And we'll talk about on Tuesday that these are very harmful, both from a static perspective and in terms of the incentives that they give for lobbying. And typically governments try to stop this by putting restrictions on people's ability to lobby. A third source might be private or illegal violence, like a mafia that has gained a monopoly power through intimidation. This is often the case in gambling industries, illegal industries, or other things that are sort of quote-unquote related to sin, because antitrust laws don't tend to be very strong there, and prohibitions on violence are not so important because people are already breaking the law in many cases. And those should be solved through law enforcement. Finally, sometimes firms can get a monopoly position just by being the first to the market, which is something that will usually resolve itself if other firms have an opportunity to enter. But transparency, reducing bureaucratic barriers can help firms to enter and compete. Now, things are trickier when a monopoly is natural. And Roman, what does it mean for a monopoly to be natural?
That there are two sources that the monopoly is natural. The first one is that there are economies of scale, and there are also economies of scope, but there is subactivity, that means that it is more efficient that one firm produces all the markets that many firms, that two or more firms produce.
Yeah.
And subactivity implies both economies of scale and economies of scope.
Yeah, so economies of scale through the full range of production is the most common reason for natural monopoly. That means that no matter how much you're producing, it's better to have, you can always produce cheaper the more that you're producing. So this will mean that a larger firm will always produce more efficiently, and therefore it never makes sense to have more than one firm. This is the most common case for a natural monopoly, but it's not necessary. So all that's actually required is what's called subadditivity, which Roman was getting at, which says that one firm can produce more efficiently than two firms can produce. But that does not necessarily imply, unlike what Roman said, that there's going to be economies of scale through the full range of production. So imagine that the common technology that all firms in the economy have has this average cost curve, right? Now, over this range over here, there are diseconomies of scale, right? But imagine that the demand curve cuts through over here. Now, it's true that this firm is now above the point where it reached the minimum average cost. But imagine that rather than this, we had two firms that were producing I didn't draw this quite right. Imagine that the demand cuts through here. Imagine that rather than having this, we had two firms that were producing half as much. That would have higher cost than one firm that's producing here, even though there aren't economies of scale at this point. So it could still make sense to have a single firm, even though there aren't economies of scale through the full range, if it's the case that wherever demand happens to be, it's more efficient to have one firm producing than two firms producing half as much. And that's called subadditivity. And that can occur without global economies of scale. And the key question will be, what is the relevant size of the market? So you could end up in this type of a situation if demand is here, but if the market gets bigger and we end up here, then it will be more efficient to have two firms producing half as much than to have one firm producing, right? So if economies of scale are true only when the firm is producing a small amount, then you'll only have a natural monopoly when the market isn't too large. And as the market gets larger, the natural monopoly will go away. Danielle Solis, what are some examples of classic examples of natural monopoly? Water services, you said? Yeah, that's a classic example. Why would you say that that's a natural monopoly?
There is a fixed cost, the infrastructure to transport the water.
Yeah.
They have no such a high extra cost they serve about
Yeah, that's exactly right. So one very common example is that you have to build a fixed infrastructure, but then operating on that infrastructure is very cheap. And so it only makes sense to build one of those infrastructures. So like, for example, running cable, telephone, or internet or video lines into people's homes has a big fixed cost. And it doesn't really make a lot of sense to have two different companies build those types of lines to people's homes. Electrical utilities are like that. Social networks can often be like that, right? Because if everyone wants to interconnect with everyone else, it doesn't make sense to have multiple different social networks. Monitoring income is another good example of that. So the government monitors your income for tax purposes, right? And imagine that you had someone else who was trying to monitor people's income in order to get them to pay something for a public good. That wouldn't be very efficient because it takes a lot of work to monitor people's income. And if you monitor my income, it is a lot easier to monitor the income of someone who I employ, because anything that I pay to them comes out of my income. And so by keeping track of my income, it's easier to keep track of their income. So that's a function that it makes a lot of sense to centralize in a government, rather than having many different agencies in charge of doing public goods creation, which would require monitoring income to figure out how much people should contribute. Public transportation has economies of scale in many contexts, though it's not obvious that there can't be some competition there, because one person could, for example, run what's it called, Transmilenio, and another person could run a subway if Columbia were ever going to build one. Okay, so the basic idea of a monopoly is that a monopoly will raise prices and reduce quantities. Why is that? Well, in order to sell more units, the monopolist is going to have to allow the price to fall on the units he's already selling. And that'll reduce his profits, right? And so there's going to be a trade-off between selling more and having a higher price. And in particular, the monopoly will choose to maximize profits, which here will be the product of price and quantity minus cost. And they won't want to set price equal to marginal cost. Instead, they want to set marginal revenue equal to marginal cost. And what, Roman, is the formula for the marginal revenue?
to differentiate benefits.
Yeah?
So there is going to be P, applying the
Yeah?
so it's going to be P plus the derivative of P
Yeah?
times
Q, that's right. So the marginal revenue formula is price plus P prime times Q. So notice there are two terms here. This is going to be set equal to marginal cost. One term is just price is set equal to marginal cost. That's good. But the second one is the derivative of price with respect to quantity times the quantity. And this term is called the market power or the Cournot distortion. It's the amount by which the quantity is distorted below its optimal level. So this distortion is proportional to, first of all, the number of units that you sell. That says that if you're a small part of a big industry, then you don't care too much about the price changing relative to getting more units sold, right? So that's the first basic intuition. If you're a small part of a large industry with a given slope of demand, you will have less incentive to reduce the quantity below price equals marginal cost. Second of all, if the amount that changing your quantity moves price, the derivative of price with respect to quantity is small because your product has a lot of close substitutes, for example, then this will be very small as well. So in some sense, both of these are saying that the size of the distortion is proportional to how big the firm is, how much it matters and how much impact it has, which is going to be the basis of the elasticity formula that we'll derive in a moment. But just to give you a sense of this, here I've graphed several common demand curves. So this is a constant elasticity demand curve. This is a negative exponential demand curve. Sorry, this is a negative exponential demand curve. This is a concave demand curve, and this is a linear demand curve. And these are their marginal revenue curves associated with them. And the way that you find the optimal price and quantity is imagine that the marginal cost were this black line here. You find the intersection between the marginal cost and imagine that the marginal cost were equal to the horizontal axis in all of these pictures. Then you find the intersection between that and the marginal revenue. That gives you the optimal quantity. You take a line up to the demand curve. That gives you the price, and you can take it over to the axis to figure out what the number is for that price. Now, the thing to notice about these different demand curves is they have very different relationships between the demand curve and the marginal revenue curve, depending on which one you have. And that's a very important thing to be aware of, because the relationship between the demand and the marginal revenue is going to be a crucial thing for so many things we'll talk about today. So for the linear curve, which is probably the one you're most used to seeing, the demand curve and the marginal revenue curve start at the same point and then descend with the marginal revenue curve being twice as steep as the demand curve. And so the demand curve and the marginal revenue curve get further away from one another at a constant rate. On the other hand, with the concave demand curve, they start again at the same point, but they diverge at an increasing rate as things go on. Now, with an exponential demand curve, it's very different. These are always a constant distance away from one another. So no matter how far you go in either direction, the vertical distance between the curves is always the same. On the other hand, with the constant elasticity demand curve, things are even further away from what's going on here. The two curves actually converge as you go further on. They're further apart the lower the quantity is. So you can get very different patterns going on, and what determines it is the curvature of the demand curve. If the demand curve is more curved, these things will tend to converge. If the demand curve is more negatively curved, like concave or linear, they'll tend to diverge. And we'll spend a fair bit of time talking about that today. Okay. So another way to write the marginal revenue curve is as the price times 1 minus the inverse of the elasticity. And Danielle, Solis, could you derive that? How do you get that formula? Either on a piece of paper and describe it to us, or you can do it on the board if you want. And don't look at the slides. So you want to turn P plus P prime times Q into P times 1 plus 1 over the elasticity. Yeah?
So if we invert this one, so we have
Yeah?
um,
And you've got a negative out front, right?
yeah. So it's the
You're very close.
yeah.
So dPdQ, what is that the same as that we had on the other slide?
Right. Ah,
Yeah, that's P prime, right? And then if we multiply that whole thing by P, what do we get? Okay, so that's the expression we had before, right? So now what is marginal revenue? Marginal revenue is P plus P prime times Q, right? Right? And now you should be able to get the answer up there. So we want to show that marginal revenue is equal to that. P plus, marginal revenue is P plus P times prime times Q.
So if we have here, so this is 1, P, and 1 is
Yep,
this
1 minus, right? Because,
I.
no, what you wrote there was right, but you should just plug in what you derived up there, right? Except you already factored out the P, so you can get rid of that there, right? Good. That's exactly the derivation. Nice job, Danielle. Okay. So one thing that this implies is that the marginal revenue is always going to be negative if demand is inelastic, if the elasticity is less than 1, right? And so the elasticity of demand is going to determine the level of prices, and you'll never produce at a point where the demand is inelastic, because there the marginal revenue is negative. You always want to produce less than that. So if you rearrange marginal revenue equals marginal cost, P times 1 minus 1 over the elasticity is equal to marginal cost, you get that price minus marginal cost divided by price is equal to the inverse elasticity. So that says that the markup, the difference between price and cost, as a fraction of the price is equal to 1 over the elasticity of demand. So this is the classic way of expressing the idea that sort of the bigger that a firm is in the market, the more percentage impact he has on price, the greater the markup that he charges is, right? If he has a big impact on price, that means that his demand is inelastic, and therefore he'll charge a big markup, right? Okay, now this definition can be a bit problematic when we have negative prices. So for example, imagine that you're a credit card company. Credit card companies often subsidize people using their cards rather than charge them a price for it, because they're getting a subsidy from the merchants. Every time someone uses a card, the merchants pay a price to the firm, so they actually have negative costs. And in that case, this formula becomes a bit nonsensical. So in that case, it's better to use the P prime times Q formula to think about market power rather than the inverse elasticity. But people use both. Okay, so this is sort of a simple story about how monopolies price, and it's sort of the standard one you learn. But you can apply it more broadly than it might initially seem. So even when there are sort of some additional wrinkles, there's a simple extension of this story that applies. So for example, imagine that you didn't know what the demand was. Then you would face a problem. You'd have to charge a price and produce a quantity without being sure that those would actually be on the demand curve. You might produce too much for that price and some could go unsold. You might produce too little for that price and some people would go unsupplied at the price. So we've assumed sort of a simple price-quantity relationship, and when demand is uncertain, you're going to have to choose both price and quantity ex ante. Nonetheless, and there's a nice paper by Michael Salinger showing this, you can still apply the Lerner rule if you think about the right notions of cost and elasticity. So the right notion of elasticity is the elasticity of the average quantity sold with respect to price. So you say, how many units on average will I sell more in percentage terms if I change the price by 1%, right? And that's the relevant elasticity. And the relevant cost is what is the cost of selling on average one more unit, right? So if I produce more, sometimes I'll end up selling that extra unit, sometimes I won't. The relevant marginal cost is the expected cost required to sell one more unit rather than to produce one more unit, which is not the same thing. Another nice example of this, of how things extend, comes from when firms try to learn about the demand for their product. Now, if you were a firm trying to learn about the demand for your product, you wouldn't already know it, so you couldn't just set a particular price. Instead, what you'd do is you'd try charging a price, and you'd sort of see how much demand there was at that price. And then you'd adjust your price, and you'd start learning about your demand, and on the basis of what you'd learned, you would choose your monopoly price in the long term, right? And then you could base your price on your past experience. Now, Ilya Segal had an even cleverer idea about how to do this. Maybe it could run into some problems in the same way the VCG mechanism would, but here's his idea. Imagine that 100 people show up at my store. And rather than charging them a price, I say to them, look, here's how it's going to work. You tell me how much you're willing to pay for my product, and I'll give you the product if it's above what the monopoly price, based on everybody else's values, would have been. So another thing I could have done is I could have set some price and said, is your value above or below that price? And I could have gone along and learned the monopoly, the demand curve that way. And as I went on, that would change what I did. But he's saying we can do this all at one moment in time, right? We can say to everyone, tell me what you're willing to pay, and I'll give you the product if your price is above the monopoly price that I would have figured out had I known what everybody else's willingness to pay was, which I got from having them report that to me. Now, everyone wants to tell you the truth because they only care whether they get the good or not, and they want to get it exactly if it's above, if their willingness to pay is above the monopoly price, right? So that's sort of a crazy way of trying to, all at one moment in time, learn about what the demand curve is, right? Okay. Now, one place where it's really feasible, maybe not to do the crazy thing that Ilya Segal was suggesting, but at least to learn about your demand, is on the internet. So on the internet, you can constantly be changing your prices, right? Imagine you're someone on eBay who sells stuff all the time. You can like play around with your prices to figure out what your demand curve is to be able to set the right price. And Laurent Einov and John Levin collected some beautiful data from eBay on this. So what they found is about 500,000 examples of cases where sellers of the exact same seller of the exact same item had played around with price or other terms of sale to see what would happen to figure out how they should do things with their product. And he said, we can exploit all of that as economists and figure out what the demand curves for things look like. So in particular, he was not looking at cases where there was just a fixed price. He was looking at eBay, where instead the thing that was being moved around was a reserve price. That's the minimum price at which the good would sell. Otherwise, if it doesn't reach that price, the auction ends without it being sold to anyone. Jaime is not here, right? Jaime Naranjo. Did anyone else read the Einov et al. article and remember this idea of what an auction demand curve is? Yeah, Danielle.
Lower starting prices will create a higher probability for the selling price.
Yep. Yep. Yeah, exactly. So if you start the price of an auction higher, if the minimum price is higher, then imagine that the person who ends up winning the auction has a higher value than the reserve price, but the next highest person is below that value, right? Then you're going to get a higher price for your good if it gets sold, right? Because that person is going to be forced to bid at least this reserve price, and that gets you a higher price. On the other hand, there's a chance that the highest person was higher than, has a value that's actually below the reserve price, in which case the thing doesn't get sold, right? So as we increase the reserve price, we get a higher price if the object gets sold, but a lower chance of the object being sold, right? And that basically traces out a demand curve. As we change the reserve price, our expected price goes up, but the demand, the quantity, the probability with which we sell the good, which is sort of like the quantity, goes down. And that, that relationship between the average price and the probability of sale as drawn out by changes in the reserve price gives us a demand curve in an auction, right? So that's kind of a useful idea. If you're ever trying to design an auction, you're trying to think about the reserve price, you can just think about it in terms of what a monopoly would do in the price quantity space, right? Where the quantity is the probability of sale and the price is the average price that you expect induced by changes in the reserve price. Okay, so here's what they found. The amazing thing about their data is that they looked at goods that had a value of between $0 and $10, $10 and $30, $30 and $100, $100 and $1,000. So these are very different price points. But what he found is that the shape of the demand curve, if you divided it by the value of the good, which is like some reference value, how much that good usually sells for, was exactly the same. Or not exactly the same, but very, very similar. They all sort of had a shape like that, right? So what you can do with this is you can take a third-degree polynomial, and you can fit it through these curves so we get something smooth. Here's what I got. That looks pretty much like the shape of all the demand curves, right? That smooth thing. Then I can take the derivative of it, and I can get the marginal revenue curve, which looks like that. Now, notice something funny about this marginal revenue curve. All the marginal revenue curves we've looked at before are declining, right? But this marginal revenue curve, it goes down, and then it comes up again, and then it goes down again. Now imagine that you're selling a good, and you face a marginal revenue curve like that. And you've got a value that's somewhere around here or somewhere around here. What are you going to do? Are you going to charge it? Are you going to choose this point, or are you going to choose this point over here? I don't know. Yeah, go ahead, Roman. What? Yeah, exactly. So imagine that I have a line, I have a cost that's cutting through here, right? What is my total profit if I choose this point? Well, it's the area below the marginal revenue curve and above my marginal cost, right? Because if you add up the marginal revenues minus the marginal costs, that's going to give you the total revenue minus the total cost, right? On the other hand, if I choose over here, I have to subtract this area down here that is below the marginal cost and above the marginal revenue. But I get to add this area over here, up there, where the marginal revenue is greater than the marginal cost. Now, that area up there is bigger than the area down here, so I'd want to choose this point here. But on the other hand, imagine my marginal cost is up here. Then, if I go over here, I have to add this whole big area down here, and I only get to, I have to lose this big area down here, and I only get to add this little area up here. So that's not a very good deal. Then I'd want to go here, right? So what we can do is we can take the line where exactly the area below is equal to the area above. That's called the ironing line. And if we find that line and iron out the curve, we can actually ignore the fact that there's area up here and area down here. And we can just treat the marginal revenue curve as if it's this thing, which is declining. It goes down, and then it's flat over this region, and then it declines. And that new ironed out marginal revenue curve will no longer present this problem to us, right? Because whenever the marginal cost is above this, we'll know to choose here. Whenever the marginal cost is below this, we'll know to choose here. But what does that tell us? If my marginal cost goes from here to just slightly above it, the quantity jumps down, and the price jumps from here to all the way up there. That says that a tiny increase in cost can lead to a discontinuous increase in price when you have one of these ironed marginal revenue curves, right? So what that basically says is that when you have demand curves that lead to this non-monotonic marginal revenue curve, and we'll talk about exactly what it is about the demand curve that does that in a minute, then you can have big, big changes in price from tiny changes in cost. And the really interesting thing that they found is that they looked at where eBay reserve prices actually were. So they looked at what reserve prices do people usually set. And they found that overwhelmingly people set reserve prices that were somewhere up here, or that they set reserve prices that were somewhere down here. That you almost never, reserve prices that were somewhere up here, or reserve prices that were somewhere down here. That is, you almost never saw people setting reserve prices in this range that you should expect from the theory they wouldn't use. So that's a really powerful confirmation of the theory of monopoly pricing. Okay. Okay, so the way that we more formally find this ironing solution is that we remember that the profit's the area between MR and MC. And so we draw a line. We take the point where there's equal area above and below, and we draw a line. Below this ironing line, we choose to the right. Above this ironing line, we choose to the left. And we replace the old marginal revenue curve with this new marginal revenue curve. OK, so monopoly is going to raise prices above costs. And that has two effects. First, it's going to transfer wealth from the consumer to the monopolist, right? Because the consumer pays higher price, monopolist gets a higher price. Now, that has distributive effects, but it doesn't lead to any net loss of social efficiency. But the second problem with the monopoly is that he reduces the quantities of goods consumed. Some individuals who would be willing to buy the good at cost and therefore would create social value by getting more utility than the cost would be, don't, because the price is higher. This creates the deadweight loss from monopoly. And the basic reason is the monopolist would like to raise prices on all the inframarginal people without having to exclude people from the market, but the problem is he can't. That's the fundamental problem. He's only able to charge more money to the people who already are buying the good by raising the prices on people who are deciding whether to buy the good or not. What that means is that if a consumer decides to buy the good, that's going to create a real externality on the monopolist. Why? Because the monopolist gets this markup on every good that gets sold that the consumer doesn't internalize. So the usual way that people think about this is that the monopoly is doing something bad by raising the prices. But you could also think the consumer is doing something bad by not purchasing the product that's monopolized, right? You can solve this problem in many ways. One way is to try to use a subsidy. So if you subsidize goods that are monopolistically produced, that will correct the problem by encouraging consumers to purchase the product, by internalizing the externality. And we'll talk on Tuesday about some of the problems with that. A second one is that you can mandate, just force the firm to charge a lower price or to produce a higher quantity. And that's the standard regulatory solution that we'll discuss in a few minutes. And third, you can do anything else that will make the consumers act as if they value the good more than they do. So for example, if you have deceptive advertising that persuades consumers that the good is worth more than it really is, that's actually beneficial if it's a monopolistically supplied good, because it persuades consumers to internalize some of the benefits to the firm of them buying the product more. Or if the monopolistically supplied goods are more prestigious, that will also help solve the problem. So that's an important thing to think about, is that when a good is monopolistically supplied, the consumers should be buying more of it, not just the monopolist should be selling more of it, right? Okay. So to measure these losses, we consider a deadweight loss triangle, which is very similar to the distortions that happen from a tax, right? The only difference is that the size of the deadweight loss triangle is determined by the monopolist's optimal choice of quantity. And this will mean that it has a particular size in relationship to monopoly profits, which we'll explore in just a minute. Now, there's two different expressions that we can give for the monopoly's deadweight loss. One is the difference between price and cost as we run from the monopoly's quantity to the socially optimal quantity. So that corresponds, let me see if I have a graph on the slide of it. No. That corresponds to, if we have a marginal cost here, demand there, and marginal revenue like this, this is the monopolist's quantity. The deadweight loss is, as we go along the quantities, the difference between the price and the marginal cost, adding up the area that way. Another way we can add up the area is as the difference between the marginal cost and the price at the monopoly's quantity of the smaller of the two of the marginal cost or supply function and the demand curve. Okay. So profits can also be written two ways. So profits can either be the square that's above the marginal cost curve and below the area that's above the marginal cost curve and below the demand curve. Sorry. This is the price. So the monopoly gets this price times this quantity and the area that's above the marginal cost curve. Right? That's probably the way that you're used to seeing the profits be written. Right? But an alternative way to do it is up to the monopoly's optimal quantity, the area between the marginal revenue curve and the marginal cost curve, right? So this is the marginal revenue, so this is how much revenue the monopoly is getting. If we add that up to this quantity and subtract off the marginal cost, we get this area here. And those two areas are the same. You can figure that out by playing with the little triangles, basically. Because this triangle here that we included is the same as this triangle here that we left out. Now, the area between the demand curve and the marginal revenue curve is how much surplus the consumers are getting, right? That's the part that the monopoly isn't able to capture as he increases his quantity. He doesn't get the full area under the demand curve as he increases his quantity. He only gets the area under the marginal revenue curve. And so the remaining area is what is captured by the consumers, right? And this is what we call the marginal surplus. Because it's the surplus that consumers earn as a result of the monopoly increasing his quantity. And that is exactly the area that the monopoly fails to internalize in producing his quantity. It's exactly equal to P prime times Q. So that distortion that we talked about before, that Cournot distortion, that market power, is exactly the marginal surplus of consumers. Okay. So I don't know if anyone looked at the syllabus that I circulated, but there's a really nice quote by Alfred Marshall on there about the fact that almost everything in economics can be illustrated by looking at the effects of a change in a tax. And I think actually people have do people have the version of the syllabus with the Marshall quote, or do they have the older version of the syllabus? No, you don't have the Marshall quote. I'll read you the Marshall quote. Let's see. So Marshall says, we may prepare the way for using as we go illustrations drawn from the incidence of taxation to throw sidelights on the problem of value. For indeed, a great part of the economic science is occupied with the diffusion throughout the community of economic changes which primarily affect some particular branch of production or consumption. And there is scarcely any economic principle which cannot be aptly illustrated by the discussion of a shifting of the effects of some tax. So, as you probably remember from your intermediate economics class, one of the most fundamental things that you do is you talk about the incidence of a tax, right? And then you use that to talk about what the effects of changes in the supply function or the demand function will be. It's sort of a basic principle. And much of monopoly theory can be understood in exactly the same way. So what I want to do now is do a very brief recap of incidence under perfect competition and then contrast it to monopoly. Because most of the things you'll be interested in monopoly can be understood with reference to the incidence of a tax under monopoly. Okay, so Anna, do you remember what the incidence of a tax is under perfect competition? Yep, and how do they split how much it makes them worse off, right? So what we talked about, what we meant by incidence is it makes them both worse off, but the question is how much worse off does it make each of them relative to one another? How is it related to elasticities in particular? The consumer will lose more, you said. So no, it's exactly the opposite. But the good thing about opposites is that there's only two of them, right? So, so the first principle, and most important principle, is that the physical incidence of a tax is irrelevant to its economic incidence. That is, it doesn't matter whether I put the tax on the consumer or put the tax on the firm. How much each of them end up having to pay as a result is exactly the same, right? What the key thing is the pass-through rate. That is, let's assume that the tax goes on to the producer rather than the consumer, just because it doesn't matter which one, because that's just a relabeling of the same thing. The amount that the price in the end ends up changing to the two of them will be the same regardless of who you initially put the tax on. So let's call the pass-through rate the amount that the price increases to the consumers when the tax increases on the producers. So that's either the amount when you put the tax on the producer, that the amount to the consumer increases, or it'll be 1 minus the amount that the price falls by if you put the tax on the consumers, right? Okay. So the second principle is that the incidence of the tax under perfect competition is split between the consumers and the producers according to rho, the pass-through rate, and 1 minus rho. The consumers bear rho of the tax increase. The producers bear 1 minus rho. So the total welfare cost is the quantity times rho for the consumers and 1 minus rho for the producers. So the key thing is that the tax is borne entirely by the two sides. That is, the total amount of tax revenue raised is split up by some amount paid by the consumers, some amount paid by the producers, right? And that basic logic comes from the envelope theorem. So the amount that consumers are harmed is how much the price they face increases times how much quantity they're buying, right? And how much the producers are harmed is how much the price they receive falls multiplied by how much quantity they're selling, right? And so the incidence, which is the ratio of how much the consumers lose to how much the producers lose, is the pass-through over 1 minus the pass-through, right? Okay. So the formula for incidence for the pass-through rate is 1 over 1 plus the ratio of elasticity of demand to elasticity of supply. So that is, the consumers bear a lot if their demand is very inelastic, right? So if the elasticity was low, the consumers would bear almost the whole thing. If the elasticity of consumer demand was high, they would bear very little, and vice versa for the suppliers. Now, Alberto Reyes is not here, right? No? Does anyone else want to try to explain why this elasticity formula holds intuitively, or derive it? Okay, so let's just derive it first. So demand has to equal the supply, and if we put a tax on it, that reduces the price that the suppliers end up getting. So let's take the derivatives, the implicit derivatives, in logarithms rather than in levels. So that says that negative of the elasticity of demand divided by price times dp dt is equal to the elasticity of supply divided by price times dp dt minus 1, because the change in tax is just 1, right? So if we then multiply both sides through by price and add these two together, you get that the elasticity of demand plus the elasticity of supply times dp dt is equal to the elasticity of supply. Then you divide through and divide both the top and the bottom by the elasticity of supply, and you get this formula. Okay, so let me try to show this graphically now and explain it intuitively. So imagine that the supply curve shifts up and the demand curve is totally inelastic, right? Then the price is going to have to shift up by exactly the amount the supply curve moved up by. On the other hand, if the demand curve is perfectly elastic, when the supply shifts up, the price to the consumer stays exactly the same, and the full amount is borne by the producers, right? Now, more generally, when the supply curve shifts up, or when the demand curve shifts down, the fraction that's borne by each side is proportional to the elasticities, right? If we're going to make this demand curve more elastic, the price to the producers would fall by more, the price to the consumers would rise by less. Okay. Now, notice that if we keep raising the price that we charge to the consumers, the tax that we put on the market, eventually we're going to kill the whole market, right? If you put a high enough tax on, the market's just going to shut down, right? And at that point, let's call that tax where the market shuts down T bar, there's not going to be any consumer surplus or any producer surplus, right? So we can now work backward from that point. Imagine we start where the market doesn't exist, and we start lowering the tax, and the market starts to come into existence. Now, when we lower the tax, the incidence is the same as when we increase the tax, except in reverse, right? And so the change in the consumer surplus is equal to the pass-through rate times the quantity, the increase in the consumer surplus, and the increase in the producer surplus is equal to 1 minus the pass-through rate times the quantity. If we now integrate that back up to where there is no tax, what you get is that the ratio of the total consumer surplus of the market before we put in any tax to the total producer surplus is equal to the average value of the pass-through rate over 1 minus the average value of the pass-through rate, where the average value of the pass-through rate is averaged over changing the tax from being 0 to being the rate that destroys the market, and weighted by the quantities that are consumed at each point. So we had this formula for local incidence, right, which was that if you increase the tax by a tiny bit, then the ratio of how much the producers, the consumers lose to how much the producers lose is equal to the pass-through rate over 1 minus the pass-through rate, right? And more globally, if you think about what's the value of the whole market existing versus the market not existing, it's going to be the average pass-through rate over 1 minus the average pass-through rate. That is to say, the destruction of the market has the exact same effect as putting a large tax on the market. And so the ratio of the costs of destroying the market, which are the benefits of the market existing, are the pass-through rate over 1 minus the pass-through rate. OK. So another way to put that is that you could say that if the elasticity of demand is high and the elasticity of supply is small, then the tax is mostly going to be borne by the supplier. But another way to put that is the supplier is getting most of the benefits of the market existing in the first place. And so when you put the tax on, you're taking away some fraction of the total benefits of the market existing in the first place, which is going to be much higher for the suppliers than the consumers if the demand is elastic and the supply is inelastic. So what I'm saying is that there's sort of an equivalence between who bears the tax and who's benefiting from the market existing in the first place. If there's a lot of consumer surplus and not much producer surplus, then the consumers will bear most of the tax. If there's a lot of producer surplus and not so much consumer surplus, then the producers will bear most of the costs of the tax. Right? So that's how you should always be thinking about incidence. Incidence is both a local thing, which says how much does a marginal bit of tax affect the two sides, and a global thing, how is the total benefits of the market existing divided between the two sides. And the link between those is just this quantity-weighted average of the pass-through rate. OK. So incidence, as Marshall said, shows up all over economics. And let me try to just point out two natural types of examples. So one is about the optimal way. So imagine that you're government and you don't care about how well off people in other countries are. You only care about your own citizens. I don't think that Sergio is here today, is he? No. Well, so you might want to put a tax on the export of goods from your country or the import of goods into your country, because that tax will fall on foreigners, at least to some extent, right? Because the incidence is split between the supply and the demand side. You're on one side of that market, right? If you're exporting, you're on the supply side. If you're importing, you're on the demand side. but at least some of the costs of that tax will be borne by the foreigners. So that's a reason why you might want to tax international trade, right? Those are called terms of trade taxes. And the gain from imposing such a tax is equal to the demand in the market currently, the current quantity in the market. But the loss that people in the country feel is equal to the pass-through rate. Imagine we're taxing imports, right? And D is the demand of imports, right? So then the consumers are going to bear rho times D plus however much the price increases times how much the demand falls times the tax that we charge. Because that's the reduction in the inframarginal tax that we're already earning from the demand going down when we put a tax on the good. Right? So if we equate these and find the optimal tax, we find that the optimal tax divided by price is equal to 1 minus the pass-through rate divided by the elasticity of demand times the pass-through rate. So that is, it's the tax over the price is equal to the 1 over the incidence times the elasticity of demand. And that's the same as 1 over the elasticity of the supply function. Right? What? Explain this whole thing again, yeah. OK, so imagine that we impose a tax, right? What is the gain that we get from imposing that tax? Well, it's the demand that's currently in the market, right? Because that's how much tax revenue we raise. But then there's a loss to our consumers, which is there's one that's direct, which is how much they have to pay, the fraction of it that they pay, so rho times D. Plus, we might lose some tax revenue that we're already earning if they decrease their demand, right? So that's rho times the tax that we're earning times the amount of the demand goes down. Now, if you just set those equal to one another and rearrange, you get that the optimal tax divided by the price is equal to 1 over the elasticity of supply. And that makes perfect sense, because that's exactly Lerner's markup rule. What you're basically doing in this process is you're making a cartel out of the domestic industry. You're using this tax as a way to take these competing firms and turn them into a monopoly, right? You're trying to get them to not import too much so that they get the optimal extraction from the foreign supply of the good, right? They're basically acting as a monopsonist. Another way to write this is 1 minus the pass-through rate over the elasticity of demand in the local market times the pass-through rate. Now, why did I choose to write it in that way as well? Well, it highlights the link to incidence, but also we'll see that even if the foreign firm is not competitive, even if it's a monopoly or an oligopoly or something like that, this basic formula will continue to hold, whereas this formula won't continue to hold. So if you think about things in terms of incidence, then whether you think about it as a monopoly or a competition, it won't matter as long as you use this formula that expresses it in terms of pass-through. Yeah, go ahead, Sebastian. Yeah, exactly. Yeah. When you just solve out for these first order conditions. So I can actually do that. We set D equal to rho D plus rho T D prime, right? And we want to solve for T, so we get that D times 1 minus rho is equal to rho T D prime, which says that T star is equal to D over T D prime, sorry, T over D over D prime times 1 minus rho over rho. And then if we divide both sides by P, this is 1 over the elasticity of demand. OK. So this is OK. So that's one version of incidence. that links the incidence formula to how much you want, how high of a tax you want to put on foreign trade. A second version that will use the global incidence formula is how much value comes from creating a new market. So Oscar, did you look at the, Oscar Serrano, did you look at the paper talking about creating the new market? Okay, so I'll just go through this. So suppose that we're thinking about building a new infrastructure project. And this infrastructure project is going to make a whole new market possible, such as like, the trade between two different regions of a country, right? Now, some of the producers in one region might offer to pitch in, because they'll benefit from the creation of this new market, because they'll get some producer surplus, right? But they don't want to give all the costs of creating the project. They want you to pay for the part that represents the consumer surplus. They're willing to give, most of the producer surplus, but they say you should pay for the consumer surplus. So the question is, how much of a subsidy should you give? Or imagine that you have a bunch of different potential projects and you can only give the subsidy for one. Which one do you want to do? Should you just do it based on how much the producers are willing to pitch in? Or should you do it on the basis of some other calculation? And the major adjustment that you want to make is you want to think, what will be the relative elasticity of supply and demand in these two markets, right? If the supply is going to be really inelastic and the demand really elastic, you don't want to give much of a subsidy because the consumers won't get much of a benefit. If the demand is really inelastic and the supply is really elastic, that's a market you want to subsidize much more. So the ratio of the total value of the project to how much the producers are willing to chip in is going to be determined by exactly this elasticity logic, this incidence logic, right? Okay, so now let's turn to monopoly. Okay, and the logic of incidence is going to differ from that under perfect competition in two ways. First, it's now going to be the marginal revenue curve, not the demand curve, that determines how much quantity you want to produce. And therefore, the pass-through is going to depend on the slope of that marginal revenue curve rather than the slope of the demand curve, which is going to be very related to the curvature of the demand curve in a way we'll talk about in a minute. The second is that under monopoly, there's already some dead weight loss, right? And so rather than the incidence of the tax just being split between the two sides, there's actually also going to be some excess burden. So the total incidence is not going to be the sum of the two. It's going to be greater than one. The tax will be more than fully borne by the two sides. So let's first consider the pass-through rate. Okay, so now what we have is that marginal revenue is equal to marginal cost plus the tax, right? And so using the implicit function theorem, we get that marginal revenue prime times dq dt is equal to marginal cost prime times dq dt plus 1. And so dq dt is equal to 1 over marginal revenue prime minus marginal cost prime, which is to say that the pass-through rate is equal to how much the quantity changes times how much changing the quantity changes the price, right? Which is that the price changes when the tax changes by the slope of the price over the slope of the marginal revenue minus the slope of the marginal cost. Now, remember that marginal revenue is equal to price plus price prime times Q. And we said that price prime times Q is the marginal surplus of consumers. The negative of that is the marginal surplus of consumers. So we can write the marginal revenue curve as price minus marginal surplus. Now, notice that if we identify the marginal cost curve with the supply function, which is what we usually do, then the slope of the marginal cost curve is price over quantity times the elasticity of supply, while P prime is equal to the negative of price over quantity times the elasticity of demand. So that means that this formula becomes pass-through is equal to the negative of price over quantity times the elasticity of demand minus the slope of the marginal surplus function minus the price over the quantity times the elasticity of demand. That comes from the fact that the first term in the derivative of marginal revenue is price prime, and the second term is the derivative of marginal surplus, plus price over the quantity times the elasticity of supply, which allows us to get this formula, which is very similar to the one that we saw for the pass-through under perfect competition. So it's 1 over 1 plus the elasticity of supply over the elasticity of demand over elasticity of supply. So far, that's exactly the same as under perfect competition, right? But the new term is the elasticity of the marginal surplus curve. Now, this is the elasticity of the marginal surplus curve with respect to the quantity. You could also write this as the elasticity of the marginal surplus curve with respect to price, so sort of turning it around, divided by the elasticity of demand. OK. So the question is, how should we interpret the elasticity of the marginal surplus curve? Well, it's basically a measure of the curvature of demand. So this is going to be greater than 1 for concave demands, 1 for linear demands, 0 for a negative exponential demand, and it's actually going to be a negative number for a log convex demand. So what does that say? The pass-through is going to be less than under competition when the demand is log concave, and it will be greater than it is under competition if the demand is log convex. Now, if it's negative enough, if the demand is log convex enough, then notice that this could be infinity, because this could wipe out these two terms. That's exactly the case that we saw with ironing. So the marginal revenue curve is going to start to slope up if demand is very convex, very log convex. So what this means is that when we think about the pass-through and the incidence under monopoly, in addition to caring about the relative elasticity of supply and demand, we now care also about the curvature of the demand function. Now, what are some intuitive ways that we could think about the curvature of the demand function? Maria, do you have any ideas? Whether it's convex or concave, what intuitive economic quantities is that related to? Yeah, so that's on the right track. Think through that a little bit more and see if you can relate it to anything that makes sort of more intuitive sense to you. Imagine that every consumer in the market is just buying one good, but different people have different values for goods. Well, that was a good start. So one way you can think about it is how much valuation of the good is there out in the tails of the distribution, right? If we change the elasticity, we're sort of changing the variance of how much people like the good. But if we change the curvature, you're changing like the kurtosis. So sort of like how many people have a really high value versus how many people just have a medium value, right? So if inelasticity is sort of like the variance evaluations, curvature is kind of like the kurtosis. And it's very much related to the power laws that we were thinking about the other day. So it turns out that fat tails are exactly equivalent to having very high log curvature, very negative elasticity of the marginal surplus. And in particular, if this were just the distribution of income, then the coefficient on the power law would exactly be equal to this elasticity of the marginal surplus. So if we're closer to the mid part of the income distribution, which looks more like a log normal distribution. This is going to be close to being like a normal distribution. Normal distribution is log concave. And so this elasticity of the marginal surplus will be positive. The pass-through will be smaller than what it is under competition. But if you're up in the top end of the income distribution, where things are very log convex, then this is going to be negative, and the pass-through is going to be greater than it would be under competition. Similarly, if you have products that have a real niche appeal, where there's a few people who really like them out in the tails of the distribution, this is going to be negative. On the other hand, if it's sort of like a mass market product where people are relatively similar, I mean, there's some variance, but there's not much out in the tails, then you're going to have a low pass-through rate relative to what you'd have under perfect competition. OK. So let me give you some graphical examples of this. Yeah, go ahead, Sebastian.
I was going to ask you about the last slide.
Yeah.
We are thinking about like the demand like a probability distribution.
Yeah.
We mentioned like all the, the preference of the demand. When we think about like normal distribution.
Exactly.
We fit closer to volume.
Yeah. Yeah, that's exactly how I was interpreting things here. And so I was thinking about, a big driver of how much you're willing to pay for a product being how much income you have, right? And then I was relating the income distribution and the properties that we know about it to the properties of the demand curve. That's not the only driver, obviously. Goods can be superior goods, in which case they grow faster with income. They could be inferior goods, in which case they grow less fast with income. And they can have things that are unrelated to income, where people just like the good more because of their personal preference. Let me ask you a question. Imagine that a good is a superior good. Would you expect it to have higher pass-through or lower pass-through?
I think because it's a superior with the income you expect to have more, no?
Yeah?
I think that would be like a low pass-through. How do you say that?
Lower pass-through. Yeah, so why would you say that it has a lower pass-through?
Because if distribution will be like more income, it will be like more particular.
Well, so if it's a superior good, that's going to exaggerate how much the willingness to pay increases with income. And we know that as income increases, things get more log convex. So if it's a superior good, you would expect that that's going to stretch things out into the tails more. And so you'll get more log convex, and therefore you're going to have a higher pass-through rate, right? If it's an inferior good, you'd expect to have a lower pass-through rate. OK, so let me just give you graphical examples of how this works. So imagine you have a concave demand curve here, right? And here's the marginal revenue curve associated with it. If the marginal cost increases, then we move to this point, which moves us up here on the demand function. You notice the price increase is much less than the cost increase. So the pass-through is less than 1 in this case. On the other end here, we have a constant elasticity demand curve. If the marginal cost increases by 1 unit, we move way up the marginal revenue curve and have a huge increase in price relative to the increase in cost. So these convex demand curves give you a much higher pass-through rate. Now that's the reason why, remember, let's go way back. We can now understand why Einov and Levin got this infinite increase in price when you had a small increase in cost. Because look at this demand curve. That's incredibly convex through most of that range, right? It's just like incredibly convex. On the other hand, we still have to worry about the elasticity of the supply function. So if the marginal cost curve is increasing, the supply function has a positive elasticity, then an increase in the marginal cost is going to lead to a relatively small increase in the supply, in the price, if the marginal cost curve is increasing pretty rapidly. So it's sort of an inelastic supply function. On the other hand, imagine the supply function is actually decreasing. So it like goes on the opposite side. Well, then a small increase in the marginal cost is going to lead you to move way up and therefore lead to a larger increase in price. Okay. Now, let's move on to incidence, which is going to now have to use a different envelope theorem. So remember, before we said that the change in the welfare of the consumers was the change in the price times the quantity, and that the change in the welfare of the firms was the change in the price to them times the quantity. But now that's not going to be true. Why? Because the monopolist has chosen the price optimally. He's a price chooser, right? So we can treat it as if the price stays fixed when the tax increases. Because by the envelope theorem, if the monopoly's chosen the price optimally, right, he doesn't care if the price changes when the tax increases by a small amount, right? And so what that says is that the full burden of the tax is borne by the monopolist. If he leaves his price the same and the tax increases, he has to pay the full cost of that tax, right? The change in the tax times the quantity. But the consumer is still, by the envelope theorem, bearing rho times the quantity. So what that says is that there's an excess burden under monopoly, which is equal to the pass-through rate times the quantity, right? That's a burden of tax that's not borne, that's borne beyond the amount of revenue that's raised. So it's no longer the case that the burden of the tax adds up to 1 times the quantity. Now the monopolist bears 1 times the quantity and the consumer bears rho times the quantity. So now the incidence, rather than being rho over 1 minus rho, is rho divided by 1. And so again, we can use the exact same argument to say that the ratio of the consumer surplus to the producer surplus is the average of that incidence, the average pass-through rate. So now the gains to trade are going to depend on the curvature of the demand function as well, right? Monopolist is going to prefer to not just to face markets with concave demand functions. Why? Because that makes the pass-through rate small. It means that the consumer gets very little of the gains from trade. So this is a very important intuition. Monopolists would like to face consumers who have very similar demands or no consumers out in the tail. He wants a very concave demand function, right? We can also relate the size of the total excess burden, the total deadweight loss of a monopoly, compared to the profits the monopoly makes using a very similar logic. Okay, let me first just give a graphical representation of this. Why is it that the monopoly bears the full cost of an increase in the tax? Well, remember that his profit is the area between the marginal revenue curve and the marginal cost curve. So imagine the marginal cost curve shifts up by a unit. How much does his profits decrease? Well, notice that this little triangle area is very small because he's chosen optimally to set the marginal revenue equal to marginal cost. So how much does his profit fall by? Well, it's basically this horizontal distance times 1 unit, the amount of the tax increase. That's the envelope theorem for the monopolist. Okay. Let's consider now the case when the monopolist has constant marginal cost. And let's imagine that another company comes into the industry and exogenously produces a quantity Q tilde. Right? Okay. So what is now going to be the optimal quantity for the monopolist to produce? Well, his first order condition is now price plus the slope of price times the amount that he produces, which is the total amount to the industry minus the amount that's being produced by this competing firm, and he's going to set that equal to cost. Now, raising that, the amount of this exogenous competition, Q tilde, is going to be equivalent to reducing his costs by an amount P prime. Why is that? He now has less goods inframarginally that he's producing for every amount that the industry produces, and therefore he has less incentive to try to keep the price up. So, reducing his quantity, his cost, by P prime times the change in Q tilde is the same as leads to an increase in the quantity supplied to the, an increase in the price to the market of P prime times the pass-through rate, right? Because we know that an increase in the cost leads to an increase in the price of the pass-through rate times the change in cost. And the change in cost that's equivalent to a change in this exogenous competition is equal to the slope of the price. Now, how much does that lead to a change in quantity? Well, to get back the quantity from the price, we divide by the slope of quantity with respect to price. Price with respect to quantity. So these two cancel out, and you get that the increase in quantity that comes from an increase in this exogenous competition is exactly equal to the pass-through rate. So how much does the total amount supplied to the industry increase when this exogenous amount supplied increases? Exactly the pass-through rate. So now we can consider the incidence of this entrance of additional competition. Again, we can use an envelope theorem. The firm has chosen its quantity optimally. So we can act as if the total quantity supplied to the industry stays fixed when this exogenous amount of competition comes in, as far as it affects the firm, because the firm has chosen the total quantity for the industry optimally. So how much money does the firm lose by this competitor coming in? Well, it's exactly the markup that he's earning on what he's producing, right? Because that's the amount that the other firm, by coming in, is stealing away from him. So he loses his markup times this increase in competition. On the other hand, how much does society gain when there's a small increase in the quantity that's supplied? Well, it gains the amount that the quantity increases to the market times the marginal distortion, which is the markup that's being earned, right? Because that's the wedge between the social value and the cost, right? That's the marginal distortion of having a lower quantity. Okay, so the change in deadweight loss when we increase the quantity is that deadweight loss falls by the amount the quantity supplied to the market increases times the markup, whereas the producer surplus falls by the amount of the markup. And we know that if we increase this exogenous quantity so much that it's supplying the efficient quantity to the market, then the deadweight loss has to be equal to 0. Right? Because if we increase the quantity to the efficient amount, there's no deadweight loss. There's also going to be no profit at that point. Because once prices are at their efficient level, there's no profit. When price is equal to marginal cost, because the firm has constant marginal cost, there's no profit. So what do we get? We can use the exact same type of argument we were doing before. We can integrate back, and we get that the change, as we change this exogenous quantity in the profits, is the markup times, integrated over the quantities. The change in the deadweight loss is the markup times the pass-through rate integrated over the quantities. And so the ratio of deadweight loss to producer surplus is the average value of the pass-through rate, now averaged weighted by the markup and over this introduction of competition. And that's very intuitive, because we said the deadweight burden of monopoly beyond the just equal splitting of the costs is exactly the pass-through rate, right? Because that's the excess burden borne to the consumers. And so this expresses that exactly, that the ratio of deadweight loss to producer surplus is this average of the pass-through rate. OK. So now we can go back to those two incidence applications that I talked about earlier, right? Let's think about the terms of trade distortions. Sebastian, can you just walk back through what we did with the terms of trade and explain how it is related now under the monopoly logic?
Yeah, like we saw that with the taxation on the trade, we're going to see like the difference of surplus between the consumers, the demand,
Yep.
and the producers. And we saw that at the optimal level of taxation, we're going to be like 1 minus the surplus.
Pass-through rate, yep. Yep.
Divide the elasticity of the demand, the pass-through times.
Yeah. And how does that change here?
In monopoly,
Yeah.
now
Imagine that the foreign producer is a monopolist now.
yeah, we saw in this case, the only ones that are gaining are the monopolist takes all the effects.
Yep.
And the consumers takes the pass-through times the amount.
Yeah. Exactly right. Yeah. So the formula is exactly the same, right? The reason the formula is exactly the same is none of the logic that we talked about had anything to do when we formulated in terms of the pass-through rate. It had nothing to do with what was going on in the foreign sector. All that mattered was the pass-through rate, right? That's how much the people in the domestic economy end up bearing. And so, again, the optimal tax is given by this formula, but is not equal to 1 over the elasticity of supply, because that's no longer what determines the pass-through rate. So if we formulate things in terms of the pass-through rate, we don't even need to think about what's going on in the foreign economy. All we need to think about is the pass-through rate, right? How about creating a new market? Maria, do you want to try to talk about how creating a new market is related to the analysis that we had before? Imagine that now we have a proposal to create a new market by some monopoly, like someone is going to have a monopolistic right to operate a concession for a port or something like that. Does anyone else want to try to relate it to what we talked about before? Well, so as I said, a common example of this is that you have a port or some other thing that's going to be run by a monopoly, and you're going to auction off the right to run that, right? Now, often we run auctions and we just base it on however much bid the person submits, which is very much related to the profit that they're going to make. That's going to allocate it to the person for whom it's most profitable to operate the concession, right? But again, we need to think not just how profitable it will be to operate it, but how much the consumers will gain, right? So again, we need to think about the total benefit of creating this market, not just the gains to the producers. And what are the total gains of the market now? Well, it's 1, which is the gains to the producers, plus the pass-through rate, which is the gains to the consumers, rather than just 1, which is the gains to the producers multiplied by their profits, right? Versus before in the competitive logic, the total gains were 1, which was 1 minus the pass-through rate plus the pass-through rate, which was the gain to the consumers, versus 1 minus the pass-through rate, which was the gain to the producers. But again, that's basically the same logic, right? The greater the pass-through rate is to the consumers, the greater we want to favor a project relative to another one holding fixed the profits. So if we want to think, if we're auctioning off a monopolistic concession, which project should we favor relative to the others conditional on the bid that they make? It should be the ones that we think will have a great high pass-through rate. So we just need to think about what are the curvature of the demand that will be created by this firm rather than the other firm? What is the supply elasticity as we thought about before? Again, we can use the exact same type of logic regardless of whether we're talking about a monopolistic or a competitive industry. The same basic logic, if we formulate it in terms of incidence and pass-through, applies. Right? Okay. So what this basically says is that in these two problems, but in many other problems, the main differences between monopoly and competition can be summarized by the way in which they impact the pass-through rate. Okay, so we're now going to turn to regulation, and let's take a 10-minute break before we do that.